Significant digits, the number and the given value of a physical quantity obtained by the actual measurement. So what this means is, first of all, the entire purpose of significant digits, or whatever you want to call it, figures, has to do with the tool you're using to take a measurement. So the bottom line of why we do this, in one word, is this. It has to do with measurement. Okay? And then it says, including the first estimated number. Whenever I use any instrument in science, there's a correct way to use an instrument. Now, last week, I told you the correct way to use a meter stick was, and this is true for any single instrument, you measure to the smallest division. So in this case, the little teeny lines are millimeters, and then you approximate between the lines, okay? And that's why that last digit is uncertain, because that's the one I'm kind of guessing on that I can't really tell. So when reading an instrument, read to its smallest division, and then you're going to estimate. And these are significant. So let me show you what I mean. Let's say I was measuring something, and I'm just going to exaggerate it up here. So let's say I had a ruler, and I was measuring in centimeters, and this was 2.0, and then this is 2.1, 2.2, and 2.3. So let's say I was measuring a block, and the block is like this. Now, if I was going to write down the correct measurement for this, I'm not going to write 2.1. I'm going to write 2.0. Why am I bothering to write this 0? I'm bothering to write this 0 to show that when I measure this, it's right on the 2.1 line. It's not 2.15. It's not 2.13. It's not 2.2. It's right on this 2.1 line. If it came here, I would write 2.15. So I'm showing that this instrument measures not to a tenth, but it measures to the hundredth. So even though it's right on the line, I still need to write down that 0, and that's why that 0 is called significant, because it shows me it's right on that line. So significant figures has to do with the instrument you're taking for measurement. That's the whole point of it. Now, all of this is in your textbook on page 18 or 19. So as we explain things today, if you're still not sure, you can also look in your book and read it on those 2 pages. So that's why it's nice to have your textbook as a resource, because a lot of times in the book they might have more diagrams. And we're all different the way we learn, so sometimes maybe reading it might help us to put it all together so we fully understand it. Okay, now there's certain rules that you've probably heard before. So found by counting so here are our 4 rules. Number 1, digits other than 0 are always significant. So what that means is 1, 2, 3, 4, 5, 6, 7, 8, 9. Whenever I see that, that's significant. Number 2, any final 0 or 0 used after the decimal point are significant. Just like I showed you a second ago with measurement, why did I write down this 0? I wrote down this 0 because I was using an instrument that measures to the hundredth. So this would be like I was using a meter stick to measure the length of something, and it was right on the 5.6 line. It was not 5.61. It was not 5.62. It was right on the line, and that's why this 0 is significant. Number 3, zeros between 2 other are significant digits. So if the 2 is significant and this other 2 is significant, these 2 in between are also significant. And number 4, 0 used solely for spacing are not significant. For rule number 4, this is where most people make a mistake, so there's an easy way to do this. The easy way to do this is you put it in scientific notation. The one rule for scientific notation is 1 integer to the left of the decimal point. So this is going to be 1, 2, 3. So this is 7 times 10 to the negative 3, and now I can easily see this has 1 significant digit. And that makes it much, much easier for rule number 4. All right, so here are some examples. 75, so this is 1, 2. This one is 4. Why is B 4? Because just think about measuring. I'm measuring something using a meter stick. A meter stick measures to 100th of a centimeter. So if I was measuring the length of something using a meter stick and it was exactly 75 centimeters, but a meter stick measures to 100th of a centimeter, that's why I write down those 2 zeros, because that means that I'm using an instrument that measures to 100th of a centimeter, and it's exactly 75 centimeters. It's not 75.01. It's not 75.02. It's exactly on the line. And that's why I write those down, and that's why they're significant. C. Now this one, what I would do is I would put this in scientific notation. So 1, 2, 3, 7.060 times 10 to the negative 3, and then I can easily see here I have 4 significant figures. 1, 2, 3, 4. Tomorrow I'm going to teach you how to use your calculator that you just press a button and it does it for you automatically. Puts it in scientific. All right, so we see here 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. Again, this 0 is significant. I would not the reason I wrote it down is it has to do with the instrument that I'm using to take a measurement. All right, let's go to the next page of notes. Now, unfortunately, you might have heard these words before, accuracy and precision. You memorize the definition. You maybe use them interchangeably. They mean 2 completely different things. But we have to understand, as far as measurement, these 2 both have to do with measurement again. That's the whole point of these. So accuracy says the degree of agreement between a measured value and the true value. Typo. Now, I'm going to give you an analogy. Now, you know what's funny? I don't understand a bullseye analogy. I'm more mathematical. So the analogy that I'm going to give you has to do with pi. So we've all learned about pi in math class. So we know that the value of pi is 3.14. It's actually 159. So let's just say it's 3.14159. So this is my value of pi. So I know that this is the actual value. That's the accepted value, correct? So this is my value of pi. Now, suppose you're doing a lab and you're going to calculate the value of pi, and instead of it being 3.14159, you get 3.14176. So this is the same, this is the same, this is the same, this is the same, but this, the last 2 digits, is different. So this is only accurate to this many decimal places. It's only accurate to 1, 2, 3 past the decimal. How do these compare according to precision? Precision has to do with the degree of exactness of an instrument to measure. So because these 2 numbers are both 1, 2, 3, 4, 5 past the decimal, this one is just as precise as that one. Okay? Now let me explain as far as why we have these, why we're going to apply the rules to measurement. So let's say I have this little block. If I was to measure the width using the ruler, it might come out to be, and I hold it up and I look, 1.1, so this might be 1.15 centimeters. If I use my vernier caliper, which is a more precise instrument, it might be 1.155 centimeters. So this instrument, this is my meter stick, this is my vernier caliper. Caliper means it grabs on, because this measures to 100th of a centimeter, and this measures to 1,000th of a centimeter, and then my micrometer is going to measure 1 further. So which one is the most precise instrument? This one is, because it measures 1 decimal place first. So that's what precision has to do with. Okay? Now, let's say I was measuring pi again, and I got 3.15, so let's say I was measuring pi and I got 3.12654, and then I used another instrument and I got 3.142. This one is more precise, right? Because it goes more decimal places. This one is more accurate because see how the 3.14 is closer to the real value of pi. Accuracy and precision, they do not mean the same thing. You do not use those words interchangeably. So why do we bother doing all this? What's the whole point of all this? So let's say, and this is just a very simple example, I had this block and I wanted to calculate the area. So area is going to be length times width times height. So let's say I did the length using a meter stick, and that was 2 past the decimal point. Then I had the vernier for this unit, and it's 3 past the decimal point. And then I have the micrometer for the other measurement. When I round my final answer, how am I going to round my final answer? Because first of all, my final answer is going to be as far as the calculator shows me, right? So my final answer has to be rounded to the least precise instrument. And that's why it's important to know significant figures, because it has to do with the instrument you're using to take a measurement. Because once you learn science, you're going to use all kinds of formulas to calculate something, whether it be area, whether it be, and someone should have corrected me because this is not area, what is this? Volume. That we have to know how are we going to round this. Okay, so that's the whole purpose of this. So precision, the degree of exactness with which a quantity is measured. Okay, and that's it. So we're going to practice.